Module 11, problem set 1. Here we're asked to come up with a Lewis diagram for ammonium cation. Let's begin by making sure we know the chemical formula associated with the ammonium cation. It's going to be NH4 carrying a positive 1 charge. Let's ratchet through our 5-step algorithm, beginning with finding the number of valence electrons. So our number of valence electrons, we've got nitrogen that is in group 5, 4 hydrogens each in group 1. We need to subtract 1 to impart that positive 1 charge to the overall molecular ion. We have 9 minus 1, a total of 8 valence electrons. We next need to identify what the central element is going to be. Recall that is never hydrogen, so clearly here that must be nitrogen. We attach the adjacent or outer atoms. We check to make sure everything has its octet or duet. Adding lone pairs of electrons is necessary. Each hydrogen has its duet. From the standpoint of that central nitrogen, we see 8 valence electrons. We now check to see that we have used the requisite number of valence electrons. There are 8 used in this diagram. Indeed, we had 8 available. We will indicate that the overall molecular ion carries a positive 1 charge. And here we have the Lewis diagram for ammonium cation. Let's do one more. So next we will do OF2. This will be the second one in problem set 1. So here we're doing OF2. Okay, let's start by finding our number of valence electrons. Oxygen is in group 6. We have 2 from group 7. So here we have 14 plus 6 for a total of 20 valence electrons. Now we need to select our central atom. We're going to go with the least electronegative. Typically, fluorine being the most electronegative element, would expect it to be a central atom. We'll put O in the middle. Also going to give our molecule a greater degree of symmetry here. So I've identified the central atom. I've attached the adjacent atoms. I now need to give everything an octet that needs an octet. Here, both fluorine and oxygen will require their octet of electrons. I've given everything an octet that needs an octet. Now step 5, let's check to see that we have used the correct number of valence electrons. We had 20 available. There's 8 around that fluorine, 8 around that fluorine. That's 16, 18, 20 valence electrons. Everything that needs an octet has an octet. This would be an acceptable Lewis diagram associated with OF2.